Okay, number 6, it says two parallel plates are 0.85 meters apart. The electric field intensity is 5.2 times 10 to the fourth newtons per coulomb. What work is done moving a charge of 3.4 times 10 to the negative 9 coulombs from one plate to the other? So if I'm looking to write down my facts, if something's in meters, then that's going to be an R because that's one of the variables here. So let's write it. Now, sometimes they'll give you facts up here, like they're giving me an R, they're giving me an electric field, they're giving me a QO, and they're asking for work. But it's not that I may have a problem where I don't have to use all those, but I'm going to list them. So if I list them, I'm going to have my R equals 0.85 meters. Now, even if they didn't use the word electric field intensity, I know it's going to be electric field intensity because the only thing that's measured in newtons per coulomb is electric field. So that number is going to be 5.2 times 10 to the fourth newtons per coulomb.
Good morning. Please excuse the interruption. We are having some work done on the fire alarm. Again, we are having some work done on the fire alarm. If the fire alarm goes off, please disregard. If the fire alarm goes off, please disregard. Thank you.
I guess I'll be doing this podcast over. All right, so now the next one, what work is done? So the unknown is W. And moving a charge from one plate to the other. So that's your QO. So 3.4 times 10 to the negative 9th, times 10 to the 9th coulombs. So those are your facts. The two of the big four here, I have E and I have W. So, and W is my unknown. So I'm actually going to do this. Since W is my unknown and QO and R are not my unknown, then I'm actually going to do it where I'm only going to adjust that side, not that side. So I'm not going to have to do algebra after I create the equation. So I'm going to write it this way. I'm going to put W and then E. And W is KQ QO over R. E is KQ over R squared. So like I said, I'm not going to touch this side. I'm only going to make this side look like that side. And whatever I do there, then I'll keep W isolated. Since it is my unknown, that's, save me a little bit of work here. So I'm going to, if I first look at the numerator, one side has KQQO and one side only has KQ. So I'm going to put in a QO. Whatever I do there, though, I do there. Since I multiplied by QO here, I'm multiplying by QO there. Now, this side has an R, this side has an R squared. I want them both to be the same thing, and I don't want to touch this side. So to make this an R, I'm going to multiply by R. So multiply by R here. Now if I look at the two down here, they're equal. KQQO over R, KQQO over R. So since those two are equal, then those are equal. And so there's my equation. W equals E times QO times R. And when I multiply all those together, hopefully I'm going to get joules, because I don't have to rearrange it now. So I'm going to put in W equals E QO R. And so for E, 5.2 times 10 to the fourth newtons per coulomb. QO is 3.4 times 10 to the negative 9th coulombs. And R is 0.85 meters. So what's great about these problems is I'm going to be able to check my work by looking at the units and seeing if I do get joules, because I know work is measured in joules. So if I look at this, the coulomb is going to cancel the coulomb, and that's the only thing that cancels, but I'm left with Newton meters. And a Newton meter is a joule, so I will get the answer in joules, and that answer came out to be 1.50 times 10 to the negative 4. All right, 1.50 times 10 to the negative 4 joules. All right, any questions on that one? Again, so all these well, I would say half of the problems are where you're doing this little manipulation of the variables f, e, v, and w to create an equation and then plugging in. About half of them. The other half are almost like vector addition type problems where you might have like a charge, like I give some sort of reference, where I have a rectangle and I have a charge in the bottom left corner and a charge in the bottom right corner. And I might say, well, what would the force be on a charge in the upper right corner? Or what would be the electric field intensity in the upper right corner? Right? Because, so, since forces and electric field intensities are vectors, those would be the other types of problems besides what I'm doing right now.